Welcome to the Discover Mathematics series. In this video, we're going to look at some special characteristics of prime, composite, and perfect square numbers. Thank you. We're going to look at the numbers between 1 and 16, and we're going to use these small tiles to find how many different rectangles we can make with given dimensions. So with the number 1, we can only make one rectangle. Now with the number 2, we can make a rectangle that is 2 by 1, and we can make a rectangle that is 1 by 2. So we can make 2 rectangles. And with the number 3, we can make a rectangle that's 3 by 1, and we can make a rectangle that's 1 by 3. Now for students, to record this, they can just draw these out on some grid paper, color them in so they'll have a record of this, and then we're going to record it on a data sheet. Okay, for the number 4, we can make a rectangle that's 4 by 1, one that's 1 by 4, and we can also make a rectangle that's 2 by 2. So using 4 tiles, we see that we end up with 3 different possible rectangles: 4 by 1, 1 by 4, and 2 by 2. Okay, for the number 5, we have 1 by 5 and 5 by 1. For the number 6, we can make this 6 by 1, 1 by 6, and we can also make a rectangle that's 3 by 2 and 1 that's 2 by 3. Okay, so we're noticing that some of these numbers allow us to make more rectangles. So I'm going to encourage you to have the students sketch them out on their paper, and then we're going to record this in a data sheet. Okay, so that's for the number 6. For the number 7, you can make this 7 by 1 and 1 by 7, and that's it. That's all we can make. For the number 8, we can make 8 by 1 and 1 by 8. But we can also make a rectangle that's 4 by 2 and another one that's 2 by 4. Okay, for the number, that's for the number 8. For the number 9, make it 9 by 1, 1 by 9, and another one that's 3 by 3. Now, of course, if students are actually building this, it's going to take them a little bit longer to play with it to figure out which ones actually make rectangles. How they can make rectangles using all of the given tiles that they have for a given number. Okay, so for the number 9, we notice that we have the 9 by 1, the 1 by 9, and we have the 3 by 3. And when we see that we have the 3 by 3, we should notice it's 3 by 3, or perfect square. For the number 10, we're going to have, that's 10 by 1, and 1 by 10, but we can also make one that's 5 by 2, and another one that's 2 by 5. Okay, so for the number 10, we end up with 4 different rectangles, 1 by 10, 10 by 1, 2 by 5, and a 5 by 2. For the number 11, we have only the 1 by 11 and the 11 by 1. And for the 12, we're going to have the 12 by 1, the 1 by 12, and then we also have a 3 by 4, okay, so we have a 3 by 4 rectangle, a 4 by 3 rectangle, and we also have a 6 by 2 and a 2 by 6. So here we actually have 6 rectangles that we can make using the number 12 as the area. Okay, for the number 13, we're going to have 13 by 1 and 1 by 13. Okay, for the number 14, of course, we're going to have another one, so it's going to be the 14 by 1 and 1 by 14. You might not be able to see it all, but it's there. And then we also have a 7 by 2 and a 2 by 7. So here's our model for 14. So we have a 14 by 1, 1 by 14, 7 by 2, and 2 by 7. For the number 15, we'll have a 15 by 1, a 1 by 15, and then we'll also have a 3 by 5. Here's a 3 by 5 and a 5 by 3. Now for the number 16, you won't be able to see the 16 by 1 and the 1 by 16. And we have a few more rectangles there, so I'm going to build them and then I'll show you. So here we have our 16 by 1, our 1 by 16, a 2 by 8, an 8 by 2, and we have a 4 by 4 rectangle. Now some of the students might say that, well, because it's a square, it doesn't count as a rectangle, so you need to help them to see that it is in fact, the square is in fact a special rectangle. Okay, and they can continue on with other numbers, but what I'm going to do now is since I've recorded the pictures, I've drawn them, and the students should draw them, then they're going to be able to go ahead and record them in a data sheet. Here is my data sheet that I'm going to go ahead and complete based on the pictures that I've drawn from when I worked with the manipulative. So first I would encourage you to have the students use the manipulative. So by them moving the tiles around, it gets them more involved, they're more likely to remember it, and then to record their pictures on graph paper so they can go ahead and complete the data sheet so we can look at so we can make some comparisons. So here's my data sheet with the dimensions of the rectangles, the number of rectangles, and the factors filled out. So next, we can tell the students that prime numbers have only two factors. And so any place where we see only two factors, we can record that that's a prime number, and I'm going to place a P on the left side of my column. So this shows me the prime numbers less than 16. 2, 3, 5, 7, 11, and 13. If you want to put the P on the other side, it doesn't matter. I just want to give you some ideas. How you share these with your students is going to be up to you. Okay, so the numbers that have more than two factors are composite numbers, and we'll label those with a C. Okay, so the numbers that have more than two factors, I designated with a C. Those are composite numbers. Now we look at the number, there's one number that's not labeled at all, and that's the number 1. Because is it prime or is it composite? Well, it doesn't meet the criteria for either one because it doesn't have two factors, it only has one. So it can't be composite, and we can only make one rectangle. So actually the number 1 is neither prime nor composite. It's like by itself. Okay, we don't have a label for it. It's just neither prime nor composite. But we also have, if we look down the column of the number of rectangles other than the number 1, then we notice that we have most of them, well, there's a certain pattern or certain difference. Some are different than most of the rest of them. And what I notice is that I have some odd ones. I have here, I have an odd number of rectangles. Here's an odd number of rectangles. Here's an odd number of rectangles. And actually here also is an odd number of rectangles. And what do we notice about those? Let's look at the dimensions of the rectangles. Okay, so I can give this students a moment to think, to see what they notice. They can go back and look at their drawing, and what they should notice is that they're perfect squares. So what I have here is my copies of my rectangles where I drew them out, all the factors. So here's my 1 by 1, it's a perfect square. Here's my 2 by 2, which is a perfect square. Here's my 3 by 3, which is a perfect square. And here's my 4 by 4, which is also a perfect square. And they can, the students think about it, it's because it's an odd number because the length and the width are exactly the same. So they don't make two different rectangles or the same rectangle with different orientation, which is why we have an odd number. But they can actually see that like 4 by 4 does in fact make a perfect square. So they can identify which ones are prime, which numbers are composite, and which numbers are perfect squares, and they can continue it past 16 if you want. It's entirely up to you. But then they have a visual representation of the difference between prime and composite numbers, and then they see which numbers are perfect squares. That completes this video. Thank you.